Welcome back to the video series on integration and differential equations. In today's video, we're going to discuss non-homogeneous DEs with constant coefficients. Here's our example for today, and let's take a look at the right side of the DE. So we've got a function of x here that's not equal to 0, and when that happens, we call the DE non-homogeneous. To rephrase, a non-homogeneous DE has either a function of x or a non-zero constant on the right side. And it will be helpful later on in the problem to have given this function a name, so we'll be calling it f of x for the purpose of this example. We're going to run through a 5-step procedure for solving this type of DE. First step, we're going to find what's called the complementary solution, or in symbols, we're just going to call that YC. So the way that we find YC is we copy down our original DE in the problem, but we're going to be setting the right side equal to 0. So this is now just a nice DE with constant coefficients. We know how to solve this DE. So let's set up the auxiliary equation. We'd have m squared minus 8m plus 15 equals 0. We can either factor or use the quadratic formula. So in this case I would factor as m minus 3 times m minus 5. That's equal to 0. And that gives us the two solutions, 3 and 5. So we're in the situation where we've got distinct real roots. And that tells us that our solution is going to look like y equals c1 e to the 3x plus c2 e to the 5x. Now, in all our previous situations, we were calling this solution y because it was the general solution to the problem. But in this case, this is just the first step towards the solution. So it's important here that we actually call this yc. This is our complementary solution. And as we go through the problem, we will be working towards the final general solution. In step 2, we're going to set up yp. In words, we would call that the particular solution. And let's have a look at how we do that. The particular solution yp has unknown coefficients and involves all terms in f of x, f prime of x, f double prime of x, and all the other derivatives. So let's try to work through this. So I would start by recalling what our f of x is. Remember, f of x is just the symbol we're using for our function of x on the right side of the DE. So in this example, it's 65 sine x. And let's calculate the first few derivatives. So f prime of x would be 65 cos x. F double prime of x would be minus 65 sine x. And we could keep going here. If we keep taking derivatives, we would get sine and cosine terms. And the coefficients would either be 65 or negative 65. Okay, so I'll write dot, 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 and we could imagine continuing this process here. So we want to ask ourselves, how many types of like terms are there? So in looking at f of x, we see a sine x term. Not too concerned about the coefficient right now, I'm just concerned about the type of like term. So we've got a sine x term, and then we've got a cos x term. And that's actually all we have. No matter how many derivatives we take here, we would only ever run into two types of like terms. So just for fun, let's write f triple prime on here that would be minus 65 cos x. Okay, so we can say that in f double prime, we're not getting anything new because sine x is something that we've already recorded. We've already run into it. And similarly with f triple prime, we're not getting anything new. It's the same type of term as we had with f prime of x. They're both cos x terms. All right, so we want to somehow record the fact that there are two types of like terms that we run into as we take derivatives of f of x. And the way we're going to record that is with our yp. So we want to say yp has a sine x term and it has a cos x term. Okay, and if we look back at the definition here, we said yp has unknown coefficients and involves all these types of terms. So we're going to call these unknown coefficients capital A, capital B. If you had more terms, you could call the coefficients capital C, capital D, etc. We really do not want to call them C1, C2. Those will come in. We've actually already seen them in the complementary solution. So don't call them C1 and C2 when you're dealing with the particular solution. Try to call them capital A, capital B, capital C, etc. Okay, so that is our particular solution. So I've created a bit more room here and recopied our results from steps 1 and 2 so that we can refer back to those. And let's move on to step 3.